welcome to today's tutorial on how to form imines and enamines from ketones or aldehydes. So, like I said, our starting products are going to be ketones or aldehydes, right? You're going to also need an amine, right? And I'm going to add a little R group there. And we're also going to need an acid catalyst. So I'm going to put a little asterisk on this to show you guys that maybe the acid catalyst can be used at the beginning or it can be used later on in the reaction mechanism. So let's go ahead and start with the first case where you actually use it in the beginning. So I'm going to use a ketone to start. Right? This is what a ketone looks like. And then I'm going to have acid first. That's the first thing I'm going to have. And this is an acid. What you're going to find is that, just change the colors here, is that these lone pairs on oxygen are going to capture this hydrogen, which will donate its electrons onto this A to make it minus. So you're going to have this. Right? And your oxygen is positive now. Oxygen has a +1 formal charge and it does not like that. So these electrons from the double bond are going to shift onto the oxygen, giving us this resonance structure. Oh wait, so now it's happy, but this carbon right here, it became positive. So now it's very, very electrophilic. And let's go back to our starting molecule. We have an amine, so an R and then an H2 with its lone pair. So then this is going to attack here, right? And you're going to form this bond. Two hydrogens and the R group around it, and then you're going to have an OH on there. Obviously the nitrogen here is also positive, and we can go ahead and just do formal charge really quickly. So I have 5 valence electrons minus I have 4 lines and 0 dots, so I have +1 charge. So let me erase this really quickly. Okay, so let me go ahead and add these electrons for oxygen as well. It's very important for you guys to always add your lone pairs because, and so obviously in the beginning we have acid, but the acid never really goes away. It's an excess, right? So at this point the acid comes into play again. And what happens is these electrons, because nitrogen has no electrons, right? If nitrogen had a lone pair of electrons, it probably could have also captured this hydrogen, but it doesn't. Right now it's full, so this oxygen is going to capture this hydrogen and it will donate its electrons to the A. And then you're going to have water with a plus charge for oxygen, and then nitrogen will have this, right? These electrons are going to capture this hydrogen, and then the hydrogen will donate its electrons to the A, right? So this A will now become A minus because it has a lone pair of electrons. So this A minus, I'm gonna go ahead and just copy it, and I'll paste it right here. Okay, this A minus has electrons that can capture this hydrogen from nitrogen because this is still positive. And then this will donate its electrons to nitrogen, right? Okay, let's move on to this next step. So I still have an OH2, and it's positive, the oxygen is positive, but now I'm gonna have this. 2 lone pairs. So this is the important step, pretty much. These two electrons on nitrogen are going to come into here form a double bond, the same time that this carbon will donate its electrons. Let me do a better job at this. These electrons onto oxygen. Because oxygen is positive and it wants to leave as water, so I'm going to have water leave here, minus H2O. And it will give me, let me go ahead and draw it like this better, right? I'll have this nitrogen, and then I'll have a hydrogen on it, and an R group on it, and now it's back to being positive, right? Okay, hope that cleared it up. Let's move on. So now I have a positive nitrogen, which is not good, right? I don't want a positive nitrogen. But before I move on, I just want to say something. This is called an iminium ion. It's an ion because it has a charge of +1, right? So this is really important because this step usually is the difference between this imine and enamines, right? Because up until this point, and I'll show you in detail what I mean. Up until this point, both of those mechanisms are going to go in the same direction, in the same way, until this step. And I'll show you what I mean in a second. So let's move on. So again, I still have this A minus being generated right? So it's going to capture this hydrogen, and then this hydrogen will donate its electrons onto nitrogen. And now nitrogen is fine because it has its lone pairs again, and it's okay. So now this is called an imine, right? So I have an R group, I have a double bond with the nitrogen, and a double. So what I can do right here to make it a little bit simpler for you guys is let me go ahead and just twist it around. Oop. Okay. So this is called an imine. And I'm just going to go ahead and explain one little thing right here. So this nitrogen has hydrogen, hydrogen, R group, and 2 lone pairs. This is called a primary amine. It's primary because only one of its constituents is an R group. The other 2 are hydrogens, right? If I had something that looks like this would be a secondary amine because now I have 2 R groups instead of 1. So this is a secondary amine. If I had something that looks like this, now I have 3 R groups, and this is called a tertiary amine. Okay, so I just wanted to clear that up a little bit. Primary amines are the ones that make imines. Secondary amines are the ones that make enamines. You can't really do anything with tertiary amines, and I'll show you why in a minute. But I'm going to go ahead and erase this because this is not really, we can't really use these for our reactions. But this is important, so I'm going to highlight it in here for you guys to pause and write it in your notes or something. Because you have to memorize that if you have a primary amine as your nucleophile, then you can make an imine, which is what we just made by this reaction, or an enamine, which is the next thing that I'm going to go ahead and make. Okay, and I'll just use this to say this is an amine. It's kind of big. Let's do this instead. Okay, next. Let's go ahead and do, so I'll just write over here, this is imine formation. Let's go over here and write enamine formation. Okay, and I'll start with the exact same thing. Right, a ketone and an acid catalyst. This is going to attack this hydrogen. It will leave this these electrons will be donated onto this A. So I'm gonna have plus A minus, right? And then these electrons are gonna go onto this oxygen, which give me this. Okay. Next up, I'm going to add my nucleophile, right? And I'll also have an H. So this is a secondary amine. So these electrons are going to attack this carbon right here, and I'll have this. And then this is going to be positive again. Okay, then again, I still have those 2 electrons, and then I still have the acid. So I'll have, whoops. A water molecule. R and R, and then didn't really leave much space there for the hydrogen, but okay. So now I'm gonna go ahead and have an acid. I mean, not an acid, but the A minus from the acid that we had, that this is generated. These electrons are gonna go ahead and capture this hydrogen. It will donate its electrons onto nitrogen. And then 2 R groups. And now it's happy again, right? And I have an OH2 group right here. So then these electrons are going to go ahead and form a double bond at the same time that these electrons are going to go onto the oxygen, making it a leaving group. So now I'm going to have N double bonded to 2 R groups. And it also has 2 R groups with a plus charge on it. So again, this is my iminium ion. And I told you guys earlier that this is an important step because let's go back here and zoom in. This iminium ion has a hydrogen on it, which I can capture from this base that I generated, right? You have an acid, and then you you take the hydrogen from the acid, that becomes the base. So this is a base. A minus is a base, right? And the base captures this acidic hydrogen that I have on this iminium ion. And then this gives me my imine. However, if I go down here, I still have a base, right, A minus, but I have no acidic hydrogens. And I can't take an R group. R groups are not, they're not very, bases can't really capture those. They can only really capture hydrogens on the groups, right? Okay. I'm gonna go ahead and erase one of these R groups. And let me just say that my R group is an ethyl group, right? So if my R group, I'll just do it right here. R is equal to ethyl group. Like I said, I don't have any acidic hydrogens attached to the nitrogen, but I do have an acidic hydrogen on these carbons. I have one here and one here. I have after this hydrogen. And then this hydrogen will donate its electrons onto this carbon, right? And I forgot about this plus sign right here, but these electrons are gonna go in here, and you're gonna have something that looks like this. Right? So this thing right here is called an enamine. And it's an enamine, the En comes from the fact that there's a double bond right here. And this is an alkene, technically. And then an amine because you have an N and then 3 R groups attached to it, right? So this should remind you of something called an enol, which basically we've seen in another video that we can make from a ketone or an aldehyde plus acid plus alcohol. Here we did the exact same thing. Instead of using an alcohol as our nucleophile, we just used an amine. So I hope that this video makes a lot of sense to you guys. I know it was kind of long, and it's kind of a little bit tricky because it's not exactly the same thing as an enol formation, right? This is a little bit more, you kind of have to think a little bit more, especially in this step right here. When you kind of get to this point, you have to remember that this oxygen is going to attack, or it's going to capture the hydrogen from the acid. A lot of times we forget that there's even acid in the solution, so we might get stuck on this point. You know, so it's with this kind of mechanism, you really just kind of have to practice it a lot of times with different things.